Welcome everyone. Great to see so many taking some time out of their busy lives to join this webinar. I'm really excited to get a chance to talk about this unexpected favorite topic of mine, which 10 years ago I had no idea I would be working in, let alone know something about. The reason I'm presenting here today is that I've worked for quite a bit of my working life for the past 10 years in plastics in one way or the other. Last decade, I worked for the Ellen MacArthur Foundation and was part of setting up, among other things, the New Plastics Economy Initiative, which was a very interesting experience in terms of learning the complexities of a system and what it takes to drive positive change in that system. Today, I work for Stena Circular Consulting, which is the consulting arm of Stena Recycling, one of the biggest recycling and waste managing organizations in Northern Europe. What we do at Circular Consulting is to take all the knowledge that comes from 80 plus years of experience in recycling, knowledge about how materials behave in the economy, how they are worn down, how they get distributed in the economy, what happens at the end of life, and using that knowledge together with what we bring from the consulting side to create new and better solutions, new and better business solutions for companies who want to drive their circular journey. But today we're going to talk about plastics, and basically I want to start with a fly-in looking at the role plastics has played in the world in the past century. And then we zoom in a lot to just establish what plastics really are, because we need to know that if we want to understand what the problem is with plastic, why is all this fuss, and having understood the problem, hopefully look at what the potential solutions are to those problems and why it's so hard to do those solutions in practice. And then finally, I'd like to end on a positive note on what we can actually do despite these challenges. So we have to talk about plastics, that's for sure. And even if that's something we could have said 10 years ago, it's still really valid. The plastics production is increasing quite rapidly. It's increasing way over kind of baseline GDP growth in the world. It's expected to be doubled by 2040 with 2016 as a baseline year, which means that given the leaky nature of the plastic system, that we will have a 3 times increased leakage rate into marine environments, in other words, the oceans. And that in itself will drive up the total volume of plastics in the oceans by a factor 4. This is, of course, because once plastics are in the oceans, they don't go away. There are cleanup operations, some of them more sophisticated than others, but they are only literally scraping the surface, because most of the plastic in the oceans are, by the way, not at the surface anyway. Magnitude of those problems in economic terms amount to something like $100 billion, as if you express them as annual financial cost, if businesses were recovered to cover the damages of all that plastic leakage as it is valued. Now, if businesses were forced to pay those costs, plastics will not be a profitable industry, basically. Now, they aren't at the moment, but it just gives an understanding of the size of the problem and how much of the real costs of plastics are externalized today. In other words, not paid for by anyone, really. So on top of that, there are many known and even more unknown effects on both human health and the environment, as expressed very condensed by a recent science paper that we're also going to return to later. So there's clearly a lot of kind of unwanted consequences with the plastic system. But surely they need to be good for something if they're there and if there's so much of it. And of course, it is an extremely versatile material that has in just a bit less than a century grown from just a few million tons of production to what we forecast to be something like 400 million tons of production by 2025. And in many ways, plastics and the advent of plastics has defined modern life. It defined what we called throwaway living, and actually hailed as a good thing in the 1950s. It has come to define also kind of the wastefulness of modern life in the 1990s, where we started to understand that, okay, there's probably a dark side to this. What really kicked off what I choose to call here the era of the plastic crisis was, I would argue, a science paper in 2015, which was the first publication to estimate how much plastics was actually leaking into the ocean. And I believe that is still the most quoted figure of roughly where we are. As you can see in that box here, it's a pretty broad range, which also speaks to the difficulty of getting accurate data in a system as complex as this one. So a lot of other stuff started to happen around 2015. There was a landmark report published by the Ocean Conservancy. The year after, the Ellen MacArthur Foundation published its new plastics economy report in Davos, at the World Economic Forum. And for those of you who have heard the saying, like there will be more plastics than fish in the ocean by 2050, that is an estimate that comes from that paper, and maybe did more than anything else to kind of raise this issue on the agenda, because it's a very kind of evocative and compelling, in a negative sense, thing to think about, right? And so from you could say there around 2015, 2016, there's been a lot of activity to try to, number one, understand the dynamics of the plastic system and why it creates a bit of a problem. And then also sort of figure out how to solve the problem. A couple of other things to call out here is that UNEP released a report in 2023 that has identified more than 13,000 different chemicals in plastics. As we'll see in a moment, plastic isn't just a polymer, it's also a lot of different additives and other chemicals. On the legislative side, we have probably heard, at least in Europe, about the plastic packaging waste regulation that has been launched and is now in kind of working its way through EU bureaucracy. That is in itself a big piece of legislation that can impact how the market uses and thinks about circulation of plastics as well. And then, of course, in the last few years, it's been the INC conferences to try to come up with a globally binding treaty on plastics pollution and how to manage that. So lots of development in just a century, and especially in the last decade or so. What are these things that we're talking about really? And what's the characteristics of plastics? Well, most of you have probably heard that plastics consist of polymers. Polymers is the scientific name of a material that consists of many repeating units, as opposed to a monomer. That is the unit that repeats. So a monomer combines, or many different monomers combine to form a polymer. And you can already at this stage imagine that with that sort of structure comes a lot of variety. You can use different monomers to make different polymers, of course. You can vary how these polymers behave by varying their length. Will there be 100 repeating units, 1,000 repeating units, maybe 1,000,000 repeating units? There's also things like branching or linearization of the polymer that affect the material properties. You can also combine different monomers to form copolymers. And one of the most common materials on the planet, PET, is a good example of a copolymer. So already here we have an almost infinite variety, and we realize that, well, so a common plastic that, like polyethylene or PET for that matter, is not really one single material, because if the polymer quality, or the polymer properties, which you can define describe in many different ways, are different. They're actually different materials. They have similarities, but there are they're not apples to apples in the sense that a monomer would be identical to another monomer. But we're not done there. We also need other things to make a plastic out of the polymers. Typically, the plastics that we meet in everyday life are called thermoplastics. They are a formulation between usually a base polymer matrix and a recipe of additives. Those additives can make up to 40 weight percent and contains anything from just sort of filling materials that are put there to make the material cheaper per kilogram, so to speak. A common filling material is ordinary chalk, but also other things that affect the properties of the polymer, making them a bit softer, or they can be used to absorb UV radiation, which could otherwise destroy the polymer and over time make the plastics more brittle, which anyone who has had things in their garden made of plastic can recognize, right? That that toy that you had lying in your sandbox may have become super brittle after just a couple of years. Even more so in Australia, where UV light is harder or stronger. There are also things like pigments, of course, and then a large group of compounds that would be defined as non-intentionally used added substances, or NIASs. And that's of course things that weren't meant to go in the plastics but go in there anyway. And we have extremely poor traceability of what those compounds are. Examples could be residues from the catalyst used when making the plastic, or from the solvent used when making the plastics. All of these things, the makeup of a polymer and how you combine the polymers to make a plastic, makes plastics as a group of materials extremely versatile. You already realize we can vary them in almost infinite combinations. We can create all sorts of physical and chemical properties that therefore also fit in almost any type of application you can imagine. And that in itself leads to the fact that we can put them in basically any type of application and product in the world, and we do. Add to that the fact that plastics are relatively cheap to produce. They are part of a massive world-scale petrochemical supply chain that is able to produce enormous volumes at a very competitive cost. The supply of these materials is also quite high. There's been a lot of supply side growth, investments made in China, but also in the US and other parts of the world, has driven up the total supply, which has driven down the price even further. And that means that it's also very hard for recycled grades to compete with virgin grades. And the technical nature of the plastic is another barrier or challenge when it comes to recirculation. We cannot, for example, easily reverse the polymerization reaction, which would have been preferable. It would make polymers more equivalent to, let's say, metals to recycle. When we recycle metals, we are in theory able to free up the atoms and recombine them to new metals and new alloys. But that is much harder and in some cases near unfeasible when it comes to plastics. The mechanical recycling, on the other hand, which is a bit more straightforward, not only are limited by the fact that there is a mixing mechanism going into the recycling process, since we're collecting plastics from various grades and with different additives in them, and we will always have something more unsorted and mixed in the recycled grade than we started with in the virgin grade. The other thing is that the mechanical recycling process, which usually contains of some form of re-extrusion of the polymer, which involves a lot of heat and mechanical force, that degrades the polymer to an extent that it loses some of its mechanical properties. Now, when it comes to recycling something for the first time, that is not I would say, a super strong detriment to the physical properties and therefore the material qualities of the plastic. It's almost like the other parts of it, the fact that the plastics come with some pollutants, it come with all this mixing that leads to something a bit grayish, something a bit smelly maybe, that you don't really know what you have. You, for example, cannot guarantee what chemicals are in there usually. That is a bigger detriment to recycled qualities than this like degradation from the actual mechanism. But overall, the nature of plastics make them hard to recirculate. So, and that also leads to a conclusion that there's no real silver bullet for how to recirculate plastics. You have probably heard a lot about, oh, we can reuse them, or we should do mechanical recycling. No, we should do chemical recycling. In reality, I think there is almost like a butterfly diagram designed for plastics, and all of these different arrows are in themselves valid. So if you have the standard linear supply chain represented by these boxes, you can recirculate plastics using all of these arcs, and what sort of level of degradation you choose is determined by the technology you apply. The further back you go, the more you can go back to square one and to the basic building blocks, and therefore you have more degrees of freedom to produce something virgin grade, even with the recycled resources, and virgin that has the qualities or the properties of virgin materials. But that also comes with a bigger investment in terms of cost and energy. If you reuse something, you don't have to do anything about the material, and it's extremely efficient from a resource point of view, but it requires kind of its own business model and its own system. For most plastics, we don't have those systems in place. And because it's such a hot topic, I'm going to spend a little time just talking about chemical recycling. It is something that a lot of people hail as kind of the big solution to the fact that we have low recycling grades today. One of the reasons we have low recycling grades is that only the kind of high quality end-of-life plastics are worth recycling. So what do we do with all the rest? Well, currently we're either landfilling them or incinerating them. But couldn't we, if we had some chemical recycling, go back to those basic building blocks, those monomers? Two of the main chemical recycling technologies are either pyrolysis or gasification. In simple terms, pyrolysis is when you heat something up in the absence of oxygens, that breaks down or breaks apart the material at a chemical level without burning it. And what that means for plastics is that you get kind of a mix of lighter hydrocarbons that go all the way from very light gaseous molecules all the way down to more solid or semi-solid materials like wax and bitumen. Gasification is similar, but it's operated at a higher temperature in the presence of, or a controlled presence of, oxygen. You can do it with a larger mix of material. So there are gasifiers that exist that take kind of general waste or a mix of biological waste and plastics and so on to kind of create the right mixture, the right operating conditions. And out from a gasifier you get syngas, which is a very versatile base to make platform chemicals like methanol with. So from the outputs of pyrolysis as well as from gasification, you can make the monomers from which you then can make new polymers. But as you can see, there's quite a few steps involved. There's a lot of pathways here that don't lead to plastics. And because this has not reached a significant scale yet, it's also hard to say how efficient it would be from a yield point of view and from an energy point of view. The best analysis that I've seen on this from a life cycle point of view is that from end to end, if you go from the mixed plastic waste going in to the polymers going out on the other side, you have maybe a yield of something like 50%. And the energy cost is significantly higher, and therefore the carbon footprint is significantly higher than for mechanical recycling. However, it's still from a carbon point of view better than incineration. But all of this comes with quite a large investment costs, and you also need an efficient system to account for the plastics that, or the molecules, I should say, that you put back into monomer and then polymer production, because you won't be able to build a separate supply chain for this. You need to plug into the existing petrochemical supply chain to make sense. So there's a kind of quite a intense debate about whether that should be, like, if we should allow a mass balance type chain of custody to count the recycled plastic molecules together with the virgin ones, or if you had some other system. I won't go more into that than just noting that we haven't solved neither the scale of chemical recycling yet, or the cost, and we haven't solved how to kind of, in a standardized way, account for that recycling in the final product. Biodegradability is another potential solution, in which case you say, hey, because it's so hard to recycle or take care of the ordinary plastics, let's make them biodegradable so that we can put them in a compost or so. Now, this is also kind of a fraught thing, because it comes, first of all, biodegradability is a term that comes with many flavors, and something that is industry compostable, for example, is not necessarily home compostable. And there's a lot of challenges where things that are labeled as compostable lead people to put things in their own garden at home, or even worse, throw it on the ground in nature, expecting them to compost, but they will be just as resilient in those environments as an ordinary plastic. In the same way, like you might say that isn't it good to have compostable or marine biodegradable plastics in ocean applications, since so much stuff in the ocean get lost and just live there forever. Well, but that is kind of a limited number of materials that actually fulfill the characteristics of marine biodegradability, and their properties are somewhat limited. So in short, the potential applications of biodegradability are there, but it's also important to make sure that there is an infrastructure to take care of them. The communication challenge when it comes to what you do with your biodegradable items is quite significant, which we should take note of given the Green Claims Directive coming into Europe as well. And actually, from an LCA point of view, it's not always a fantastic case to switch from, let's say, an ordinary recyclable plastics to a biodegradable plastic. Okay, so far we've talked about different end-of-life solutions, but what about the other side of things? What about the products we design made of plastics? How can we work there to make plastics more adapted and circular? Well, one is, of course, to work on the material to make sure we have either better designed plastics or something that is a substitute for plastic. So some examples here, you see on the left-hand side here, Mars bars that actually use a paper wrapping now rather than a plastic wrapping. Paper wrapping that, even if they have films made of some form of polymer, are recyclable in the paper recycling stream. Below we have form pressed utensils made of paper, kind of showcasing some of the things that we have traditionally made out of plastics before, but they could just as well be made of wood-based fiber. The pouch you see there is a plastic pouch, but the difference between the ordinary pouch that we usually see in the store is that this is made out of a monomaterial. It's still a layered product, but it's layered with basically the same different formulations of the same material. So it can be recycled as a monomaterial, as opposed to a lot of these other film-based plastics that are actually multi-material and therefore has no real potential for at least mechanical recycling. So that's quite a significant innovation if it got applied more broadly. Or you can do something more out there, like the innovators at Notpla, formerly known as Skipping Rock Slabs, who have created a film material from seaweed that can hold liquid. It can also be used as liners in food boxes and so on, that allow it to be composted along with food residue and so on. So there's lots of different things you can do on the material side. And what's quite, at least for me, comforting is that even if we don't hear about it in the daily narrative, you see innovations like these make incremental headway almost every week. if you follow the news from the plastic world. The other part of this is to design better business models that don't have to rely so much on single-use plastic that become waste fast. And what you see here on the images is basically different takes on a reuse, refill type business model, which does not need single-use plastics. Now, if you scale those models just a little bit, you're actually knocking loads and loads of hard to recycle single-use plastics off the material system. However, designing them in such a way that they make economic sense, that they are convenient for the consumer, and that their LCA footprint is still favorable, right, is significantly challenging. We're seeing similar to the left-hand side, still progress here, even though the progress is somewhat sluggish. It's worth to note that in the packaging and packaging waste regulation proposal, there are some quite strong wording to drive more reuse and refill systems in, for example, in the retail space. So what I tried to illustrate with the last couple of slides here is that in order to create a better plastic system, we cannot focus on just improving recycling or create new end-of-life management technologies. We also need to improve the packaging and the plastics we put into the system itself. These things need to be done kind of in tandem, because neither of the two can wait for the others, for where the chips fall on the other side. They are interdependent. And I think herein lies a lot of the why this is hard as well. We all want, in the end of the day, a better system, and we need to work on better reuse, recycling solutions. We also need to work on better products that are easy to recycle and reuse and so on. And yeah, why is it hard? Well, developing new technologies or new business models is technically difficult and costly. And you're comparing yourself against an extremely low-cost baseline. There are a lot of externalized costs that the plastic system bring, but right now nobody's paying for those costs, meaning that baseline we're comparing against can remain low. We have become so dependent on plastics, right? As I described earlier, they are part of almost all different applications you can imagine. They have driven down costs of products. They have enabled new kinds of products that we have come to rely on and love, and so on. The whole global supply chain, especially when it comes to distribution, packaged goods, and so on, is totally dependent on plastics to function the way it does today, delivering food and other products to consumers around the world. So we're trying to challenge a system that has been very deeply ingrained in society. And then, of course, it's impossible not to mention that there are also entrenched interests, right? Economies or markets or companies that have a huge stake in producing virgin plastics and or other petroleum-based products are, of course, interested in keeping it that way. Anything else would be very strange. So getting both those countries and those industries to be part of the transition is particularly challenging. I will not say that they are not part of the transition. A lot of the chemical recycling innovation, for example, investments come from the petrochemical sector. At the same time, it's kind of a, as for everyone, it's a question of survival. And if you're interested in your own survival, it's natural to try to oppose a change that goes against your survival. The fact that this is a complex issue, I hope that I have illustrated with some clarity that this is complex. The fact that it is complex means that policymakers who will be have to be part of the solution and have to be part of sort of dictating the conditions of the solutions, they need to be engaged, but they also need to be up to speed with how this works. And if it's not let's say, a winning issue at the ballot box, it's a bit harder to ask for politicians to pay close enough attention to get to that level of knowledge. So that's another complicating factor, I'd say. But with that being said, since the linear plastics economy is so externalized, or the costs of the linear plastic economy is so externalized, making the alternative, a circular economy for plastic, competitive requires somebody to pay for that cost. And if that is not handled automatically by the market, somebody else needs to enforce that payment. And that leads to the conclusion that it's very hard to increase circularity for plastics much above what we're doing today, the current baseline, if you will, if we also don't have enabling legislation that drives the market in that direction. And that brings us to the discussion about the Global Plastics Treaty that concluded in this last weekend. I won't bore you with too many of the details here. A couple of the things that were on the table was to curb the plastic emission in different ways, so making sure that plastic don't leak to the extent it does today into oceans and other environments. Mandating or putting at least the mechanisms in place for a global producer responsibility to be adopted. I'll note that in Europe, for example, there is already a producer responsibility for several of the key plastics containing value chains, but not at the global level. Transparency in labeling, monitoring, and reporting plastics and their chemicals was another big topic. Obligation to phase out substances of concern, given that some of those 13,000 substances are known to be harmful, and that's materials that we are currently using in, for example, our food packaging. And the most contentious issue, to curb primary plastics production. In other words, put a limit on how much virgin plastics is allowed to get produced. And I think more than anything else, that last topic is one where it will be simply impossible to reach a consensus, at least at the moment. However, a very large coalition of businesses and countries have come out in favor of a ambitious global plastics treaty. For example, the Business Coalition for a Global Plastics Treaty. And what's interesting when we talk about the efficacy of policy, an article really published in Science just a few weeks before the Busan conference, they looked at sort of with the modeling, with the model that they had built, they looked at which policies had what kind of impact on global plastics pollution. And it found that 4 policies in particular could together minimize the amount of mismanaged plastic waste. In other words, such that either leaks directly into the nature or is burnt in open pit landfills. That could be lowered by 91%. It would reduce the plastic production by 31%, while at the same time increasing the absolute production of secondary or recycled plastics, and it would lower emissions by 36%. Those policies are, in short, to put the requirement of 40% on recycled content in products, curb the primary plastics production as was proposed in the treaty, allocate a fund, I guess similar to your climate adaptation fund that is part of the Paris Agreement, to help especially developing economies build the necessary waste management infrastructure, and then finally put a tax on virgin plastic packaging to reduce the consumption of the material. Not necessarily the packaging, but the material. By now we know how the negotiations in Busan concluded. Unfortunately, they concluded without a treaty. Perhaps given the contentious nature of the topics on the table, that wasn't too unexpected. What is interesting and perhaps somewhat positive to note is that more than 100 countries came out in favor of the proposed ambition level. So we are in a situation similar to the climate negotiations in the Conference of Parties, where there is an overwhelming majority that wants to do more, but because the mechanism requires a unanimous consensus, you don't get there. But it does also mean that a lot of stakeholders out there, both on a national level and on a business level, want to do more. And a great way for anyone really to contribute to create a more circular economy for plastic is to act as if those policies were already in place and take steps to, let's say, source more recycled content. And it will come, at least on European level, legal requirements for more recycled content. Design products to optimize for more circularity, whether you are designing a mobile phone, vacuum cleaner, or the next wrapper for your confectionery. You can design those plastics items to be more adapted for circularity. You can develop new business models to prolong utilizations of materials, either through reuse of packaging or through service agreements or so, that keeps products relevant and functioning for longer, requiring less primary raw material. Work together with other stakeholders to ensure that products and packaging are properly collected at end of life. After all, like, one of the biggest leakage points of plastics overall is that they don't get collected properly and enter the appropriate waste management system. Even in Europe, that is way more advanced in most aspects of both having policies and mechanisms in place to manage plastics. Our collection rates and recycling rates are very low still. So there's a lot of headspace to improve here. And then finally, whether you are an individual, a company, an office or so, a housing association, if you separate your plastics at its source to produce as pure fractions as possible, you're also maximizing the value, and you're making it more likely that those plastics can be reprocessed and resold in new material applications, rather than be deemed too costly or too low value and therefore end up in the incinerator. So lots of things and lots of actions you can take while waiting for maybe more incentives from the legal point of view, or more demand signals from your customers, whatever it may be. And if you want to learn more or discuss more, don't hesitate to reach out. After all, this is my most unexpected favorite topic to talk about. So with that, I will say thank you for your time, and if there's still time for questions, I'm happy to take some questions.
Thank you, Mats. We do have 3 questions, and let's start with the one that connects to what you were just talking about. How can Stena Recycling and Stena Circular Consulting help its customers design the right solutions or recommend the direction for change?
There's a couple of handles to grab onto this issue, right? From a product point of view, looking at what the function of the plastic is in that product is a good way to start, and then trying to figure out, okay, how do we solve that functionality with as low impact from that material point of view as possible? What is possible to do, for example, in terms of increasing the recycled content there? Is it possible to use less plastic, or in some cases even a substitute? So a product design approach, basically. The other one is to look at how the product design actually ensures that the plastics that you are using do get recycled and recirculated. And there's a surprising number of things that you may not think about that does affect the recyclability of a product and its materials. That has nothing to do with the materials themselves. Another angle you can start looking at is from your sourcing writ large as a company. Like, what is your strategy to source the materials that you're using? How can you put the right KPIs and the right demand signals to your supply chain in place to drive them to help you reach higher degrees of circularity in your plastics? So those are quite sort of operationally close. You can also raise your gaze a bit more on the horizon and approach it from a strategic angle, which can be helpful if you don't have a natural place to start. what I see kind of companies that work successfully with this, they almost unanimously set a quite ambitious North Star goal, be it on reducing the amount of plastics that they use from a baseline, or improving the circularity of the plastic use, and put the number on it, right? A timeline and a number. Now, there's probably many of you have heard stories about companies that set these goals and then fail and have to kind of walk them back. But I tend to think that like that also is a little bit beside the point. The point of having those goals is to have a direction of travel that you can work towards. If you then fail, at least you fail trying, and you get somewhere while trying. A lot of factors can influence the feasibility of reaching the goal you set 5 years ago. And we know here in 2024 that a war that broke out in Ukraine did a lot to change the economic conditions. And that has contributed to how ambitious companies have been able to be in certain aspects, right? But if you have a North Star, you have something to kind of organize and start creating projects around. If you don't have that, you're kind of flailing a bit. And yes, you can do things, but how do you connect them to the broader thrust or the broader momentum of what you're doing? And just the last kind of comparison is that if you work with like the Traffic Safety Authority, I don't think any traffic safety authority has any other vision for traffic safety than 0 deaths. Now, you can argue that this is an unfeasible vision to have, because in what country do you have absolute 0 deaths in traffic in a year? At the same time, you know, what other goal should you set that feels ambitious? Should we set a goal of 5 deaths? That just seems strange, right? So in a similar way, you need to set yourself an ambition goal in order to kind of have the momentum and the energy to work towards it. You may not get there in the time you have designed, but at least you will have you set yourself the sort of structure and the mechanisms to start working. Thanks a lot, and thanks for joining.